Okay, our last amide reactions is hydrolysis via aqueous base. All right, so our process is still hydrolysis, but our reaction name is base. So in this case, we are using a strong base to cleave that connection in the amide. So we are literally cleaving this bond. So what will end up forming, and I think the easiest way to remember this is that if you are reacting with a base, that is going to give you your base organic compound. So remember, with acid hydrolysis, we formed our acid organic compound. With base hydrolysis, we are forming our base organic compound. And remember that with the other one, with acid hydrolysis, we formed an amine salt. Here, we're going to form our carboxylate salt. So what happens here is that essentially what happens is that the OH reconnects with the carboxylic acid, but the ammonia really, or the nitrogen really wants that hydrogen, which is why we end up with a neutral organic base. Because that acid ended up giving up its hydrogen, it is going to form that salt. And since we have a carboxylate that's going to be very attracted to the sodium ion, so that is what's going to give us our salt. So base hydrolysis is always going to give us our organic base plus our carboxylate salt, which is our conjugate base. Okay, so brief summary here. With base hydrolysis, your two reactants are an amide and your strong base. These conditions are under water and heat. Remember that those bases, they are going to form ions. So again, we do have ions floating around in solution that's going to help us cleave that, that bond. So again, our conditions are water and heat, and then our products will be our amine, that's our base, and our other product will be our carboxylate salt, and that is our conjugate base.